Hello, everyone. My name's Lewis, and I'm going to be talking about computers. I love computers. So, this is going to be a video of me rambling on about stuff that I know about computers because computers are fun. I'm going to stop talking about computers and let's get into the video. So, the first thing I'm going to talk about is the CPU. Essentially, the CPU is the central processing unit. It processes everything. The CPU also stands for central processing unit, by the way. And it processes web pages loading, processes opening, anything that's not visual is processed by that. So you're sending a message on like WhatsApp on your computer, CPU. You're loading a web page, CPU. You're doing anything, it's the CPU is contributing in some way. And how the CPU works is it essentially either lets an electron through or blocks it. It's kind of complicated, but essentially this is a gate. This is an electron. If it's a 1, the electron goes right through. Whoops. If it's a 0, the electron doesn't exactly go through. So I'm going to move on, and that's basically the basic explanation of a CPU. I'm going to be condensing all of these down. So if you want to see a full in-depth one, you can go watch a 20-minute video on a CPU entirely. They're very complicated, but that's the general way of how they work. They have certain cores amounts, and essentially the cores are like mini CPUs, and they can process different things at a different time. Intel come up with a new technology about P cores and E cores. It's like performance cores for high performance tasks, like 3D modeling, anything intensive, and then efficiency cores for lower process tasks like browsing the internet. Moving on, let's go ahead and talk about the motherboard. The motherboard is essentially the ground of a Lego set. Like everything is apart and, separated. But when you put them all in that ground, they become like, unified and could work together. So essentially, the motherboard does the same exact thing, except for more expensive and more complicated computer parts. So it links everything together, like the CPU, the RAM, graphics card. I'll explain all of these in a second, but it links all of them together and allows them to work in unison. Moving on, let's talk about the CPU cooler. The CPU cooler cools the CPU. Now you might be thinking, why does the CPU need to be cooled? Well, whenever it's doing all this processing and all that, it gets kind of hot. Like when you're running and working out, you get hot and you start sweating. The sweat is the equivalent of the CPU cooler. Your sweat cools you down, and the CPU cooler does the same thing. The CPU is doing a lot of work, it needs to be cooled, otherwise it will overheat and fry itself. Now, before that happens, the CPU will shut down and, it won't fry itself on purpose. But older CPUs, like really old ones, didn't have measures to protect that and they'll fry themselves. But those are really old, and 99% of the CPUs that still function have this feature. So the CPU cooler cools your CPU so that it functions correctly and, doesn't get hot. There's a bunch of different ones like the AIO cooler, which is an all-in-one, which essentially has a water cooler which has water in it. The water travels to this little copper block, which is touching the CPU, and copper is highly conductive. If you listen to your science teacher in like 7th grade, you'd know this, it's conductive. So when it touches it, the water transfers the heat to it, the copper transfers the heat to the water, and then the water goes up to the radiator, which has a bunch of fans in it. The fans cool the water by blowing air, and then the water gets sent back down to go grab more heat, go up to the cooler, cool itself, goes right back down the cycle. The next one is a fan cooler, which instead of using water to transfer it just uses copper, and then it goes into a heat sink, which essentially is just like a bunch of highly conductive material, and then it just kind of blows a bunch of air through that to cool it. So it takes the heat from the CPU, goes up in a bunch of copper or any highly conductive material, and then gets air blown through it by 2 fans, or maybe 1 fan or multiple fans. It depends on the CPU cooler you're getting. And you also have full-blown ones that are completely water-cooled, like they have tubes in them. Very cool looking, but they can go wrong fairly quickly. Now, if you set them up correctly, they won't go wrong at all. But if you're a novice, you probably should do some experimenting before you decide to go right into water cooling, because it probably won't end well for you. Just make sure you know what you're doing when you're doing that full-blown water cooling, but AIOs and fan coolers are fairly easy to install and fairly safe. Moving on, we're going to talk about the RAM or random access memory. Essentially, what random access memory is it's memory that needs to be accessed quickly. Like when you're opening a application, that needs to be accessed quickly so the CPU can process everything that's going on. Like if you move your mouse, it needs to be processed quickly. Or whenever you're moving around a web page, opening a new tab, playing a video, it needs to be processed all quickly. So essentially, it takes it from the storage, if you're playing a game, opening an application, takes it from that long-term storage, loads it into the RAM so it can be quickly accessed. Because when it's in the storage isn't quick enough to keep up with the CPU. The RAM still isn't quick enough, but it's 99 times quicker. I'm pretty sure it's more like 1,000, but it's much faster than the storage ever wishes it could be. It's like Usain Bolt compared to a turtle. It's not exactly gonna, the turtle isn't gonna win. It's not the tortoise and the hare. Usain Bolt's gonna win no matter how many naps he takes. Moving on, we're gonna talk about the storage, which is the long-term storage for your computer. Now you might be thinking, why don't we just store it all in the RAM? The RAM's like 1,000 times faster, like you said before. Well, the RAM can't hold data for long. It can only hold data when power is supplied to it. And when you turn off your computer, you can't exactly keep power supplied to the RAM, otherwise it's going to be racking up your electricity bill like nobody's business. So you have to use long-term storage, which can hold data without having a charge. So these consist of SSDs or hard drives. Now, hard drives are usually cheaper and have more capacity, but they're much, much slower than SSDs are. But you might be thinking, what's the point of getting it fast when it's just going to be loaded into the RAM? Well, when you're loading up a game or application, it's loading all of this stuff from the storage and shoving it into the RAM. So when you have a slow hard drive, it's going to be extremely slow. It's going to be like, but when you have an SSD, it's going to be throwing it around like crazy. So that if you want like faster opening times for if you're opening like Premiere Pro, a game, 3D modeling, if you want faster load times, go with an SSD. I recommend going with an SSD for your main operating system like Windows and all of your most frequently accessed stuff. Like, I don't know if you're a video editor, but you put Premiere Pro on that. But everything you need to access quickly, put it on the SSD, and then things like photos or videos, things for mass storage that you don't access quickly, put that on the hard drive. Hard drives are very slow at booting, and when you turn on your computer, it can take a long time as it's loading all of this stuff for the operating system to run into the RAM so that it, actually works. Moving on, we're going to talk about the graphics card. The reason I didn't mention this first is because it's kind of a culmination of the CPU, RAM, and power supply, which I'll talk about later. But essentially, it's like a mini computer. So the graphics card is a mini computer that you plug into a PCIe slot on your motherboard. It's essentially like a little interface that allows other third-party things to talk to the computer, like a graphics card. Usually places in the top slot, as that one has the most bandwidth. Basically, it can carry the most data and carries it quickly. So you want to do that, otherwise your graphics card won't exactly be going fast. If you have yours in somewhere other than the top slot, and it's not because you don't have enough space to fit it there, put it in the top slot, please. You're slowing your computer down unnecessarily for no reason. Put it in the topmost slot. It will increase your performance by I don't know the exact measurement, depending on the GPU, it might be different, but it will speed up your computer. So it's a mini computer. It has GDDR6, at least the current generation. It might be GDDR9 or GDDR7. I believe GDDR7 is coming out with that NVIDIA 4000 series. But it has RAM, a processor, and essentially it's just a mini computer that handles processing of the visuals. Now this can be in the CPU itself. It's known as an IGP or integrated graphics card. And essentially it's pretty slow, but it can process graphics. So most laptops have this, and some big full computers have this. Moving on, power supply. The power supply supplies power to the computer. It's really simple. It supplies power to the computer so the computer can function. Boom, bam, pow. Moving on, the case. The case is not really something you need your computer to run at all. I mean, if you don't have one, you're going to need to start your computer with a screwdriver, so that's not exactly fun. But it essentially houses everything and allows you to put fans in your computer, which blow air towards your components so that they don't overheat. Like the RAM doesn't have an included fan with it, so how is the heat supposed to get off there? It does have a heat spreader, but that will only do you so much good. The next thing I'm going to talk about isn't really a part of the computer, it's software. And the software is the BIOS. It's essentially the motherboard settings, and it allows you to change the RAM timings, which is a whole complicated process. I'm not going to begin to explain it because it's complicated. But it allows you to change your computer settings for your different devices plugged in. Like I mentioned, you can change your RAM timings. You can activate XMP, which is another thing for RAM. It's just your computer settings to make it perform better or worse sometimes if you do it the wrong way. So the only setting you should really change is activate XMP if it's not enabled. And if your computer becomes unstable, because sometimes it will, the motherboard won't be able to support that speed, you can always just head back into your BIOS and turn it off again. So that's basically everything I want to talk about in this video. There's only a couple more things I didn't mention, like a keyboard and mouse, but it's a button, and then when the button gets pushed, it sends an input to your computer telling it what to do. But everything I want to talk about in this video has been concluded. I don't know why I said it like that, but if you enjoyed or if it was helpful, leave a like and subscribe. Helps out the channel, and it's free. So catch you guys in the next video. You gonna say it with me this time? Say it with me. Peace. I'm out of here. Peace. I didn't slide under the camera frame.